Welcome to the next module, which is about types and scope. Now, you already learned something about types in the previous module, about the different types variables can have, but the types you saw there can be categorized into categories, and I want to talk about that, and I'll explain what scope is and why it is important. So let's start with the types. In JavaScript, we have, as I said, two categories, and the first category are primitive types. Primitive types are, for example, numbers, but also strings or booleans. If we use such a primitive type and assign it to a variable, like here, where I give my variable a the value 5, then in the memory, this variable will be stored, or this value will be stored. So somewhere in the memory, a value of 5 will be stored. If I now retrieve this value or try to log this variable, for example, I'm accessing this memory. I could add another variable, b, and I assign a to that. In memory, what happens is that a copy is created, which means b now also has a value of 5, but it's not pointing to the variable a, but instead the value is actually copied. This means if I were to change a to, let's say, 10, then b would still be 5 because, again, we copied the value. That's different with the second group of types, reference types. Reference types are, for example, arrays, or arrays in the end are just objects, so you could say objects are reference types. The special thing about reference types is if I create a variable here, and notice that here I assign an object which again has a field named a with a value of 5. In memory, yes, this object is stored, this object I created here, but the variable does not actually hold this value, but it holds a pointer pointing towards this value. So the object is created in memory, and the variable actually only has a pointer to this value. That's the difference to primitive types, where the variable would directly hold the value. If I now create a new variable, b, and I again assign a to it, then I'm not actually copying the value, not the object in the memory, but the pointer. And this approach is of course taken because objects can be very complex data structures. And in order not to pollute the memory with thousands of copies of these structures, instead only pointers are saved and only one instance of the actual object is generated. But this behavior does have some implications, as I will show you now.